There is a moderate risk of severe weather today across portions of the Deep South. This does include Arkansas, Louisiana, and Mississippi, with a risk for significant tornadoes from Monroe, Louisiana, northeastward toward Memphis, Tennessee. And in this video, we're looking at what might come together to support this outbreak of severe weather and a strong tornado risk. Now, we do have some cloud cover this morning, but importantly, the low-level clouds streaming northward indicate where that moisture is advecting toward the north, and we do have a very moist air mass already present. Surface observations depicting surface dew points all the way into the mid-60s already, even upper 60s toward low 70s. And with sustained low-level flow today, we are expecting that to be maintained and even focused as we head later into the day. Now, the main feature we're looking at of interest at the jet stream level is this initially positive trough over the southwest that is not extremely strong at first, but as we head this through the day, it encounters higher pressure off to the east, and that produces a strengthening mid-level jet over the Ozarks, Mississippi Valley area, providing support for surface low development as well as increasing the deep layer wind shear across this region here. Also, red dashed lines, 500 millbar temperatures, those are falling and providing for further instability. Now, as we head into the evening, this is the surface low, which is going to be deepening as it moves toward the Ohio Valley through the night into the morning. And we've also got this prefrontal trough here delineated near the Mississippi River. That could be providing a trigger for thunderstorm development because based on 925 millibar streamlines, we can see where they are starting to converge. We get that confluence right in through here during the afternoon hours. And as we play that forward, it moves off to the east and provides that support for further thunderstorms right across the Mississippi River area and further to the east. That could provide a variety of storm modes, including QLCS and discrete supercells, which should be organized because we do have deep layer wind shear crossing that prefrontal trough on the order, right in through here, on the order of 50 to 60 knots, which is supportive of organized storms, including organized supercells. And at 850 millibars, that pressure response is generating some pretty good low-level flow already. That's supporting that very moist air mass, so we don't have to worry about moisture. But as the pressure falls become a little more concentrated during the evening, and we head into the evening hours, that does lead to a strengthening low-level jet, southerly, maybe southwesterly here, across the moderate risk area. 850 millibar winds, maybe 50 to 60 knots, perhaps locally higher. That's supporting a strong low-level wind environment and increasing the hodograph length and curvature here with the storm relativity. Now, this map from Weather Nerds, we are looking at the shaded areas of 0 to 1 SRH combined with the lines that represent surface-based CAPE. And so we can see, playing this forward here, where we start to see those shaded values increase. That's the low-level storm relativity starting to increase with that low-level jet. And playing it into the evening, it goes further into Louisiana, Mississippi, surrounding areas, combined with sufficient CAPE for organized and strong updrafts. So this area here is where we combine strong low-level wind shear with that CAPE. And we're talking about the moisture. Moisture is going to be lifting northward with that low-level jet. It's already present, but it's going to be focused along the corridor by this evening, right across the Mississippi River area, Louisiana, Arkansas, Mississippi. That's right where the moderate risk is, so that moisture is feeding right into where these storms are developing and supporting continued instability. Also supporting instability is a little bit of an EML today. It is pretty strong, pretty well defined over Texas, and that is providing some inhibition during the morning hours across Texas, Louisiana, Mississippi. That's why we're at first not getting a lot of thunderstorms developing within a very moist air mass. But as we play this forward, it does become a little more diffuse during the day. So lapse rates a little bit weaker, but still maintaining mid-level lapse rates on the order of maybe 7 degrees, maybe a little bit higher Celsius per kilometer. So EML influences moving off to the east toward Mississippi, Arkansas, Louisiana. As it does become a little more diffuse and we do get cooling temperatures aloft, that does weaken the convective inhibition that I did mention just a bit ago. So it supports an environment of increasing instability, decreasing inhibition, and by the afternoon and evening hours, here we are. That zone of CAPE moving northward is through the mixed layer cape value calculation, we've got values of about 1,500, maybe upwards of 1,800 joules per kilogram. That is pretty substantial. It could be higher, but we do have that cloud cover. We do have relatively cool surface temperatures because we're not getting direct heating in some areas. It could go higher, though, if we do get better heating and we do get better lapse rate steepness. So perhaps up to 2,000 joules in some areas, but right now looking like 1,500 to maybe 1,800 in this area. I do apologize for that. What might this look like in a sounding? Well, this is a RAP sounding for this evening near the Greenville, Mississippi area. And we see the instability plotted right here on the left side. This is the positive area. This is where that cape is. And it is pretty deep and substantial. Also, you do still see those EML influences right here. Not as strong as earlier, so we don't have as much inhibition. We got a little bit, but not enough to really inhibit thunderstorms. But it is still present. Now, the moist layer. This is very deep and very high in relative humidity. So we've got really low LFC heights, really low LCL heights, and also a layer where supercell rear flank downdrafts will be sinking into this high relative humidity air mass and not evaporating as much. So we've got more buoyant RFDs to work with. The hodograph right up here does favor significant organization of storms and maybe some long-lived intense supercells. You've got that length and curvature in the low levels and deep layer wind shear that is really strong on the order of 58 knots right here for 0 to 6 kilometer. 0 to 8 is also pretty strong, supporting some organized storms. We could have better vertical wind profile for a stronger low-level shear profile. The curvature is there, but not as strong as what you might want for a longer, more curved hodograph. So that might be a little bit of a weakness in this event, but still very strong curvature in the 0 to 3 kilometer layer and length provided by that strengthening low-level jet. It is possible that because of this very high relative humidity air mass with this really low LFC height, that we do get some pretty rapid and pretty efficient convective development near that prefrontal trough today. That might provide some clustering, so that might be a bit of an issue with some of these storms. But based on this parameter space, you can see down here, STP 3 to 4, that is, and a possible hazard type of PDS tornado, that suggests that we're dealing with an environment here that could support strong tornadoes with discrete storms. Now we're going to look at the rapid refresh simulation for composite reflectivity, simulated reflectivity with updraft helicity tracks. Now, this is not necessarily how things will evolve, but it gives you an idea of how things might evolve as we head through the day. Now, during the afternoon, there's that clustering taking place here. Initially, right along that prefrontal trough near it, so we get that QLCS mode, but ahead of it, we do have some development taking place across northeast Louisiana. That might be our discrete supercells. And we do have that playing forward here. We've got the potential, as was shown right there, for discrete supercells across portions of the moderate risk area with very long helicity tracks indicating the potential for long-lived mesocyclones. And through that, we could have a potential for some strong tornadoes. Now, playing that forward during the night, it does congeal across portions of northern Mississippi and Tennessee into more of a line of storms. So damaging wind becoming an increasing risk across northeast Mississippi, Mississippi, northern Alabama, central Tennessee, also some tornadoes possible, and then finally we get to northern Georgia, the Atlanta metro, by the morning hours. But it is this region right in through here where we are concerned about the potential for some long-lived, organized, discrete supercells capable of significant tornadoes. This is going to be happening as we're heading into the nighttime hours with poor visibility, really low cloud bases, potentially HP storms. That makes it a dangerous storm. Have a way to receive warnings and have a plan to take shelter as these storms move into the area and provide some dangerous tornado risk this evening. This has been a severe weather briefing for March 24th, 2023.